Today, let's discuss calculation of probability. There are so many possible cases of probability calculation. We cannot discuss all of them. We'll discuss something very useful or frequently used, especially in this lecture. The first thing would be permutation. You might studied already. The counting number of ways to select all objects out of n object can be calculated in this manner. Starting from n, we multiply all numbers. This is permutation. From time to time, we calculate probability using permutation. We'll see example. Special case is the number of ways to list all n object would be n permutation n. It become multiplication of all this descending number. We denote it as n factorial. Another important tool to calculate probability is combination. It is a number of ways to select R object out of n object without considering the order. This is important. Permutation do not consider order. Okay? Combination do not consider order after selection. That's the difference. Because of that, n combination R can be calculated from the permutation divided by R factorial. Just one example. Suppose there are 4 people, A, B, C, D, and you have 4 chairs. Obtain the total number of cases in which 4 people are placed and the number in which A is placed on the leftmost. It looks like this. There are 4 persons, 4 chairs. Therefore, select one by one. In the first selection, you have 4 choices. After you select one person, 3 persons remain. There are 3 possible choices. After you select 2 persons, you have 2 choices. Lastly, you have only 1 choice. Therefore, multiplication of this one, that's 4 factorial, is 24, is the total number of cases. What is the event A? Is put A in the leftmost. That means we have 3 persons, B, C, D. We put it in 3 chairs, and that is similarly is just 3 factorial. So what is the probability of this A is placed on the leftmost? Well, divide the total number of cases of this one by 4 factorial. Another example is you have 4 security guards. Each morning we are selecting 2. You put one person at the front and the other person at the rear. Can you notice that it is a permutation? Because you select 2 persons and put it in the either front or back, therefore there's an order. What is the total number of cases? It looks like 4 times 3. For the first selection, 4 cases. Second selection, 3 cases. If you want to put person A at the front gate, you have 3 persons, B, C, D, and then you have only 1 position, the rear guard. Therefore, it's 3 permutation 1. The probability is divide this 3 permutation 1 by 4 permutation 2. That's 1/4. Yes, another example which is frequently used in statistics. There are 40 students. 25 students are taking economics. 30 students are taking political science, but 20 students are taking both subjects. Describing this kind of information, I think Venn diagram is very useful. Economics, there are 25 students, but 20 students are taking both economics and political science. you can classify in this way. I mean, 5% imply only taking economics. Similarly, there are 30 students who is taking political, but there are 20 students who are taking both. Therefore, 10 students is only taking political science. If you adding up, that's 35. Therefore, 5 students is not taking any course. What is the probability either economics or political science? Well, it implies this area. There are 35 students, either or imply taking one or both. That's the interpretation. In general, we denote that this is intersection event. A, you have a set notation like this, intersection event B, if you are taking both courses. I mean, this is either A or B, okay, taking one, but it includes taking both. Well, we call this is intersection event and this is union event. The union event can be calculated in this manner. A union B is addition of PA, this area, plus PB. Therefore, the intersection event included twice. Therefore, you have to subtract that. This calculation shows same result, 35 out of 40. We call this is addition rule. This is general rule. A union B can be presented in this way. There is a special case. This intersection event is null. In the case, it is just addition of two probability. If there is no intersection event, we call event A and B are mutually exclusive. Well, this rule is used a lot in statistics. Let's consider another simple example. Whenever you consider the addition rule, think about taking statistics or economics like that. Here's another example. 30 students, 10 male, 20 females. One of male student is from province. 5 of female are from the province. If you have this kind of information, it would be helpful to write down in this manner. There are situations, there are male student, female student, and somebody is from Baku, somebody is from province. Total number of male is 10, and total number of female student is 20. It looks like this. Therefore, you can specify all this area is to be 9, 15. Therefore, this number is 6. This number is 24. Then you are done to calculate this probability. Well, this is a detailed calculation of table. What is the probability he is from province? We denote it as PC. It's 6 out of 30. Another thing is what is the probability that A student is from a province among female? But that implies among female there are 20 students and 5 of them is from province. 5 out of 20 is the answer, but we use this notation, probability from province out of female. Okay, 5 out of female, we call this is a conditional probability, conditioned on female student. Then third one is probability of male from a province. Male from a province, Well, province imply the look like this is condition. Out of 6 students, there are 1 male. Therefore, answer look like this. The last question is probability M intersection B. What is M intersection B? Probability of male also from Baku is both A and B is nothing but 9 out of 30. In this situation, the 9 out of 30 can be calculated in several ways. One way is to calculate the 9 out of 30, you may calculate the 10 out of 30 multiplied by 9 out of 10. Okay? Well, like this. It has the same answer. There's another way to calculate 9 out of 30 considering this 24. First calculate probability of Baku 24 out of 30 multiplied by 9 out of 24. There are 2 ways. Okay? Well, if you have this kind of expression, maybe you'd better familiar with this notation. You can immediately notice that this conditional probabilities can be calculated in this manner. Okay? Probability B conditioned M, what is that? B conditioned by M, this M. Out of 10, you select 9. It can be calculated in this manner. Also, I already calculated these things. It has the same answer, 9 out of 30. In general, this is we call it conditional probability. Out of total probability PB, we calculate the intersection B. Rather than notation, why don't you remember this table? Then you can do everything. In general, the calculation of a intersection event, A intersection B, can be written in this way. You multiply PB here. Well, that's another way. PB times P, A given B. Here's another expression. We call it, this is multiplication rule of probability. There are special cases such that condition A doesn't play any role. It looks like PB. In that case, it is PA intersection B can be calculated in this way. We call it A and B is an independent event. Let's consider example. Tiger team has probability to beat lion. It's a 0.7 probability. As a recent statistic, we are going to have 2 games. Well, in double match, what is the probability that Tiger winning both game? Assume that winning 1 game does not affect winning the other. Therefore, winning 2 games, the first one is A, second one denoted B, it is nothing but multiplication. So we apply the multiplication rule when 2 events are independent. Here's another example related topic. Consider this table. It is a similar table with the previous one. There are 30 students, but the distribution look like different. What it look like? I mean, out of 30, it's a half percent from Baku or from province. Maybe in each male and female, we have same ratio. Okay. In that case, if you calculate M intersection B, what is M intersection B? That is 5 out of 30. Also, if you calculate the PM, what is PM? That is 10 out of 30. What is PB? This is 15 out of 30. If you have this number, you can immediately check 5 over 30 is just a multiplication of this number, right? In the case we call Meil and Baku are independent. But in this example, if you calculate every probability, this is intersection event, Meil and province, you can see that in order to calculate this, calculate the probability of province, calculate the probability of Meil, multiply, you will get that number. All item, you can see that there's a multiplication. In that case, these two attributes, gender and some location, some region, we call this is independent. We'll study this issue in chapter 11. Here's another important example. This is application of combination. There are 6 products. 2 of them are defective. What is the probability at least one defective product will be found when 3 have been selected? Okay. Well, assume it is without replacement. Then probability of finding 1 would be in 3 products look like this. Total possibility of selection is 6 combination 3. We have 2 of them are defective, therefore finding 1 defect, 2 of which are defective. That means 4 of them are good item. Therefore select 1 defect is when you select 3, from the 2 defective, select 1. From the 4 good items, select 2, will be finding 1 defect. Okay. Well, the selection of good item and then defective item, they are independent, we multiply. This is the probability calculation. And if these 2 are the defective, then you may say out of 2 defective items, select 2. Out of 4 good items, select 1. In the selection of 3, it looks like this. We call it, this is hypergeometric probability. We'll discuss that. The third one is maybe probability at least 1 defect. Maybe you can say addition of these 2. Okay, this is finding 1 defect, finding 2 defect. Okay, addition of this one look like this. But you may consider whenever you see at least this word, you can subtract from 1 such that select all 3 from the good item. It's the same answer. This is we call complementary event. Calculation of probability using the complementary event look like this. This probability can be calculated 1 minus of A probability.